If you're an educator, then you need to know how valence bond theory explains chemical bonds in the simplest way possible. This theory is fundamental in understanding how atoms come together to form the molecules that make up everything around us. Whether you're teaching high school students or college undergraduates, grasping the basics of valence bond theory can make a world of difference in how you convey the intricacies of chemical bonding. Valence bond theory, or VBT, is like the matchmaker of the atomic world. It helps us understand why certain atoms are attracted to each other and how they form stable bonds. Think of it as the chemistry behind chemistry, the foundational concept that explains why molecules have the shapes and properties they do. It explains how atoms bond to form molecules by using the principles of quantum mechanics. Quantum mechanics might sound intimidating, but in the context of VBT, it helps us understand the behavior of electrons in atoms and how these electrons interact to form bonds. This is crucial for predicting the structure and reactivity of molecules. Here's how it works. Imagine each atom has a single electron to share. These electrons are located in regions called orbitals, which are like clouds where the electrons are most likely to be found. Each orbital can hold a certain number of electrons, and the way these orbitals overlap determines the type of bond that forms. When these atoms come close, their orbitals, think of them as electron clouds, overlap. This overlap allows the electrons to be shared between the atoms, creating a bond. The extent and nature of this overlap are what determine the strength and type of the bond. This overlap has to be just right, in direction and distance, to create the lowest possible energy state. If the atoms are too far apart, the overlap is insufficient and no bond forms. If they are too close, the repulsion between the nuclei becomes too strong. The optimal distance allows for maximum overlap and the most stable bond. Now, let's talk types of bonds. Understanding the different types of bonds is essential for predicting the properties of molecules. There are primarily two types of bonds that VBT helps us understand: sigma bonds and pi bonds. When orbitals overlap end to end, we get a sigma bond. This is the strongest type of bond. Sigma bonds are formed by the head-on overlap of orbitals, which allows for a high degree of electron sharing and a strong bond. But when orbitals overlap side by side, that's a pi bond, which is a bit weaker. Pi bonds result from the sideways overlap of orbitals, which is less effective than the head-on overlap of sigma bonds. However, pi bonds are still crucial for the structure and reactivity of many molecules. Within a molecule, electrons still hang out in their own atomic orbitals. These orbitals can be thought of as the homes of the electrons, where they spend most of their time. Even when atoms bond, the electrons don't completely leave their original orbitals. Instead, the orbitals overlap and share electrons. But the magic happens when the electrons of one atom feel the pull of another atom's nucleus. This attraction is what drives the formation of bonds. The positively charged nucleus of one atom attracts the negatively charged electrons of another, leading to a stable bond. This attraction leads to the formation of covalent bonds, where each atom contributes one electron to the bond. Covalent bonds are the glue that holds molecules together, allowing for the formation of complex structures and the diversity of chemical compounds we see in nature. So there you have it, valence bond theory in a nutshell. This theory provides a simple yet powerful framework for understanding how atoms bond to form molecules. By grasping the basics of VBT, you can unlock a deeper understanding of the chemical world. Next time you see a molecule, you'll know the science that holds it together. You'll appreciate the intricate dance of electrons and nuclei that creates the bonds holding the molecule together. Thanks for watching. Don't forget to like and subscribe for more bite-sized science lessons. Stay curious and keep exploring the fascinating world of chemistry.